Okay, welcome to your lesson on special right triangles. My apologies for not being here today. My daughter is at home sick, so um, sorry about that. So the title of your notes, so this is in your math spiral if you haven't been told already. We are working with special right triangles. And this is related to our lesson on Pythagorean theorem, but we're going to take this a little bit further today. What I'd like you to do first is you're going to, with your straight edge, draw a couple of right triangles, and they're going to be what are called 45, 45, 90, or isosceles right triangles. Sorry, I got interrupted by Mr. Hunter there. So these are called isosceles right or 45, 45, 90 triangles because if we know, for instance, that the side length on the two legs on this right triangle are both 3, then we know that it's isosceles, and thus the two smaller angles both have to be the same. They both have to be 45 degrees. My apologies for my handwriting on this today. Same as every day, I guess. So I want you to draw a couple of these 45, 45, 90, these isosceles right triangles. And on at least these first couple of examples, I'm just going to give you the two legs. You may note that they're given with congruent angles or given the angle measures. Honestly, if you have your picture drawn correctly, or if you have the right amount of information, if we just know this is, say, 12 and 12 on this one, then we know that these have to be 45-degree angles because it has to be isosceles. All right, go ahead and pause the video now, and I would like you all to work in your groups to find the missing side length on each of, or find the hypotenuse on each of these triangles. And then I want you to look with your group and see what kind of pattern you see with the side lengths. Okay, so as you can see, I've got my work shown up here, found the missing side length for the smallest triangle. Side length ends up being 3 radical 2. For the middle size one, it's 6 root 2. For the largest one, 12 square root of 2. Notice how, hopefully you saw this pattern in your group, that the hypotenuse is always the shorter leg times the square root of 2. That will always happen with these types of triangles, which again are called isosceles right triangles. Or 45, 45, 90 triangles. And that's one of the two patterns we're going to use today. So, practicing a couple more like this. So, I'm going to have you all try to use this pattern instead. I'm going to give you a couple of easy ones. Or, sorry, I guess we'll say quick ones. So, if this side length was 5, and we know that these two sides are the same, and this is a right triangle, hopefully we realize this hypotenuse would have to be 5 times the square root of 2. So this is just going to be 5 radical 2, if that's all the information we have. Or, again, pretty quickly with this one, let's say that we had that each of these side lengths were 7 and 7. We know that these two angles are congruent. Then this side length has to be, I have no idea if you all are actually answering right now, probably weirded out by hearing my voice from, beyond the classroom, but this side length would have to be 7 square root of 2. As a general rule, so make sure you get this one down as well, if you have a 45, 45, 90 triangle, so if we know these two angles are 45 degrees, if this side length is S, that's an S, trust me, not a 5. Well, it really does look like a 5, especially with the first one. But if the two side lengths are S, then the rule is always that the hypotenuse is S square root of 2. So make sure you have that down. Okay, so applying this to some harder problems, or some of the ones we're going to have to work a little bit backwards, you might have a problem where you were given the hypotenuse rather than the length of the leg. So go ahead and draw this picture. So go ahead and draw another 45, 45, 90 triangle. And let's say instead that I gave you that the hypotenuse was 12. So whereas when we had the length of the legs, we were multiplying by the square root of 2. With this, we're going to be dividing by the square root of 2 to find the shorter leg. So I'm going to take 12 divided by the square root of 2. And then here's where we have to do a bit of a reminder on algebra. We've been working with radicals the last couple of days. And one thing you learned last year in algebra is that it is not considered to be fully simplified if you have a radical in the denominator. So we need to do what's called rationalizing the denominator. So we're going to multiply both the numerator and the denominator by, and we talked about this property the other day, if we multiply both the numerator and the denominator by the square root of 2, first of all, this is okay because this square root of 2 over the square root of 2 is just equal to 1. But what it does for us, well, the numerator is easy. It's just 12 square root of 2. But the nice thing is on the bottom, the square root of 2 times the square root of 2, we know that just simplifies to 2. And then our final step with this is we need to divide 12 by 2, so this ends up being 6 square root of 2. So let's try another one like that. And again, if at any point in time you will need to pause, please do. I know that I'm probably going a little bit fast, but I'm also trying to make sure I get all this recorded for you before I have to leave for the day. So similar problem. Notice how sometimes you're given the two congruent angles, sometimes you're given the two congruent sides. Regardless, it tells you it's a 45, 45, 90. So let's say that this hypotenuse was 16. Go ahead and I want you to work through this one with your partner. And so go ahead and pause the video, then we'll check it here in a moment. Okay, so hopefully you are ready to check your answer. Here's my work. Notice how, again, I divided by the square root of 2, rationalized the denominator by multiplying by radical 2 over radical 2, and it simplified to 8 square root of 2. One other type of problem to look at with this is if it doesn't simplify quite as nicely as the last one. So let's say we had, again, an isosceles right triangle. Turn it upside down this time, so switch it up a little bit. And let's say that this side length was 11. Well, I'm still going to divide by the square root of 2, and some of you all might have started seeing a pattern with the last two. We need to be careful if it's an odd number, because it's going to, in this case, it's going to give us 11 square root of 2 over 2. Again, I'm rationalizing my denominator. I divided by 2, and sorry, I should have marked this as a right angle before. But dividing by square root of 2, rationalize the denominator. 11 square root of 2 over 2. What we do not want to do is try to take 11 divided by 2 and say it's 5.5 square root of 2. This is considered simplest radical form. Having decimals in your answer, something like this, 5.5 square root of 2, this is not considered simplest radical form, so please watch out for that. Okay, so I'm going to give you 3 more problems to practice, and then we're going to move on to a second type of special right triangle. Okay, so here are the 3 problems I would like you to work through with your group. Then check them with your group, and then I'll put up answers here in a moment. Go ahead and pause the video now. Okay, hopefully you're ready to check your answers. And so for the first triangle, I got 7 square root of 2 is the length of the hypotenuse. Unintentionally, we got the same answer for the second one, even though we were working backwards. And then on the third one, we got 13 square root of 2 over 2. I'm skipping some of my work here just because I want to make sure we get everything covered in this screencast. If you can see some of the patterns here, as far as when you divide by 2, you get 7 square root of 2. When you have an odd number, you get that number square root of 2 over 2. If you're seeing those patterns and you're comfortable with that, that's fine. I won't take off points if you can save yourself some steps there. Okay, the next type of problem we're going to look at are what are called 30, 60, 90 triangles. And if we had more time, or if I were in the class today, I had spent some more time explaining this to you, and my apologies, maybe we can talk about this when I get back. But for these types of triangles, so these are called 30, 60, 90 triangles. So go ahead and draw a picture of a right triangle. The smaller angle here is going to be 30 degrees. This larger one is going to be 60 degrees. There's also a special relationship that develops. So I'm going to give you some of the information on a couple of triangles, and I want you to find the hypotenuse and see if you can find a general rule to help you out with this. So if I told you that this side length right here was 3, and that this one was 6, and in these special, or in these 30, 60, 90 triangles, the hypotenuse will always be twice the length of the shorter leg. I want you to try to find the missing leg on this one using Pythagorean theorem. So I'm going to put a couple of different triangles up here. As soon as you see all 3 of them up on the screen, go ahead and pause, and then I want you to find that missing side with your group and see if you can find a pattern. Again, write your answer in simplest radical form. Okay, so here are your 3 right triangles. I want you to, again, solve these with your group. Find the shorter leg on these. Notice how, again, the hypotenuse is always double the length of the shorter leg. So go ahead and pause the video now, and then we'll check it in a couple moments. Okay, so you can see my answers showing up here. I found for the missing side lengths, and notice how these were always ended up having to subtract. And I'm skipping a little bit of work on here, but I feel like we can handle it. This missing side length was 3 square root of 3. Up here, the missing side length was 5 square root of 3. And on this one, the missing side length was 7 square root of 3 after all that simplifying. And the pattern with these types of problems, with these 30, 60, 90 triangles, is that this longer of the two legs is always going to be the shorter leg times the square root of 3. With the 45, 45, 90 triangles that we already did, it was times the square root of 2. With these, it's the shorter leg times the square root of 3. So 7 times the square root of 3 is 7 radical 3. 5 times the square root of 3, 5 radical 3. 3 times the square root of 3 is 3 square root of 3. So with these, the difference is that we need to find, our goal always needs to be to figure out this shorter leg. Once we have that, we should be able to figure out the longer one. So let's go ahead and try another problem related to this. So I'm going to go ahead and draw a special, or one of these special right triangles, these 30, 60, 90. So 60 degrees, 30 degrees here. And I'm going to give you that the hypotenuse is 12. And this is all the information you need. That's what's different about these problems. You don't have to have more than one side length. So if I have this side length here, then we know that this shorter leg is going to be half the length. So this one's going to end up being 6. So just 12 divided by 2 is 6. And then this longer leg is going to be 6 times the square root of 3, so just 6 radical 3. And so as a general rule, so let's kind of draw a general picture here. If I have a 30, 60, 90 triangle, so here's 60, here's my 30. If we know the side length S, that's an S, again, not a 5, for the shorter leg, then we know that this is going to be twice that length, so this is going to be 2S, and this is going to be S times the square root of 3. That will always work out. Go ahead and pause the video here so you can get that written down. Okay, and hopefully we're ready to move on to practice a few more problems. So, some of these are going to be a little bit easier like that, so let me give you one more, maybe two more like that really fast. And I'll have you talk through these with your group. So in a moment here, I'll have the pictures pop up. So now that the pictures are here, go ahead and pause, get those two problems copied down, and then work through those with your group. Find the missing side lengths. Go ahead and pause now. Okay, I feel like with this type of problem, I feel like the trickiest part is just making sure you recognize what side length you have. Just know if you have the hypotenuse, you're going to divide by 2 to find the shorter side, or the shortest leg. If you have the shortest leg, multiply by 2. And it's always the shortest leg is the key one. If we can find that, everything else should kind of fall into place. So I found this was half of 18 was 9. This is 9 radical 3. Over here, half of 20 is 10. This ended up being 10 radical 3. Now, not every one of these problems will be this easy. So we're going to go ahead and draw another 30, 60, 90 triangle. That'll come up here in a second. I want you to copy down. If you need to pause, please do. Magic, there's my picture. On this one, we're given the longer leg. So because we have the longer leg and we need to find the shorter one, instead of multiplying by square root of 3, we need to divide by the square root of 3 because we need it to get smaller to become the smaller side. So this one over here is going to become 9 divided by the square root of 3. And just like we did before, we're going to have to rationalize the denominator, but this time by multiplying by square root of 3 over the square root of 3. We get 9 radical 3 over 3, and this ends up just simplifying to 3 radical 3. And then from here, to double that, to find the length of the hypotenuse, 2 times 3, this gives us 6 square root of 3. Go ahead and pause the video after these next two pictures show up. Okay, so here they are. Go ahead and pause, get those copied down. Okay, so we're going to go ahead and work through these. On this one, I'm going to divide by, or actually go ahead and work through this with your group. And again, go ahead and pause the video. Sorry about that. Okay, you'll notice on the problem on the left, it worked out kind of nicely. Again, when I divided by the square root of 3, I got 4 square root of 3, doubled it to get 8 square root of 3. On the one on the right here, a little bit messier. Dividing by the square root of 3, just like our earlier problems with the 45, 45, 90, doesn't simplify nicely, so I have to leave it as 10 square root of 3. And then when we double this to find our hypotenuse, I'm going to take 10 times 2. This would give me 20 square root of 3 over 3. I wish I had a little bit more time to explain this for you all, but my time is about to run out on my screencast.